Things are heating up, literally. The global demand of energy increases rapidly. It has been estimated that the energy demand will grow more than 28% by 2040. Nowadays, we rely heavily on non renewable fossil fuels. There is a tendency to decarbonize our fuels. That gives us a lot of opportunity to innovation and new sustainable energy. Microbial fuel cell, MFCs, has recently been attracted a considerable interest. But what is that? They are bioelectrochemical transducers, which can be used on small scale applications. Is a system producing energy from tiny microorganisms, which function as a catalyst to turn chemical energy into electrical energy.
A microbial fuel cell consists of an anode and cathode separated by a proton exchange membranes PEM. Organic substrates are oxidized by active biocatalysts in the anode and produce electrons and protons. Then the protons are conducted to the cathode through the PEM and electrons are conveyed through the external circuit. Protons and electrons are reacted in the cathode chamber along with parallel reduction of oxygen to water. Here are reactions in the microbial fuel cell anode and cathode using acetic acid as a fuel.
Several different bacteria can be used as a catalyst in MSC, including Escherichia coli, Geobacter sulforeducens, Saccharomyces cerevisiae, and D-sulfovibrio desulforicans. Anorganics like glucose, acetate, lactose, and sewage sludge can all be used as a substrate.
But there are some pros and cons that must be considered. Some pros are that it is a renewable energy, so it doesn't produce any emissions. You can save costs from treating wastewater. Uses bacteria, so it will clean the environment. And can be a way to exploit the value of sewage sludges. Some cons are that it is only used so far in small-scale uses, that it is a new technology, and only produce low power density because cannot be run continuously. There is high cost for material for the catalyst, and
cannot operate extremely low temperatures.
Imagine Josh, he's a huge music fan and he went to Glastonbury Music Festival in 2017. When he went to the toilet, his urine has been filtered through an MFC stack. His liquids have been converted into voltage, then they would pass through power harvester for energy storage. The battery stack was made of lithium iron phosphate cylindrical cells. This is followed by a regulator system which down-regulates the high voltage from the batteries to a value suitable of 2.5 volts to power the 6 LED lights. This initiative is called P-Power and has grown since their first trial.
Other applications of the fuel cell could be wastewater treatment and hydrogen production. Although microbial fuel cell is still baby technology, there are optimistic expectations of what can be done with them in the future.